Right, this evening on the bench I'm looking at this Audiolab 8000A stereo integrated amplifier from late 80s, early 90s. You've probably seen this amplifier before if you've watched any of my other previous videos. I bought this a couple of years ago from a chap locally. It seemed to work fine, apart from it did seem to take a long time for it to release the protection relays, which I just thought was probably, you know, the timer built in maybe, or it just had a slightly high offset on the DC. Wasn't sure. It seemed to sound fine. Inside looked okay. And I went to use this about a month ago and turned it on, and it never released the relay protection. For those who don't know what I'm talking about, this is a DC coupled amplifier, and like a lot of the sort of amplifiers of this era, most amplifiers now, I suppose, apart from they're going over to different technology, Class AB amplifiers from sort of like the late 80s onwards were all direct coupled, which basically means the output of the amplifier's got no series capacitor in it, and it relies on the center point of the two junctions of the transistor being at 0 volts before it will allow you to connect the speakers. And basically all that does means that if you haven't got that protection circuitry, if you switch the amplifier on, you can put a high DC into your speakers, and speakers don't like DC. It will damage them. It will burn them out. Basically, burn the voice coils out. So basically, that's what this protection circuitry does. It prevents the speakers being connected if there's a fault with the amplifier, or even you can actually sort of like connect a completely direct coupled amplifier, whereas the input to the amplifier is all DC coupled and there's no series capacitor inside. You can put a DC element on the front end, like a connection to your iPod or something like that. It's got a slight amount of DC on, and it will be amplified through the amplifier, and enough to cause damage to the speakers. So the bottom line is the amplifier is in protection, or that's what it looks like, because it won't release the relay. And I'll demonstrate that now. I'll switch it on, and you should hear a click. And by now you should have heard a relay. It's actually just clicked in. Now that's interesting, because I've had it done this before, and it hasn't done that. So I still think there's a fault. Let's turn it off. It could be because of the temperature in the room, because it's very warm in here. Turn it on again. No. Yeah, it has come in this time, but it's taking forever. It shouldn't be that long. So this amplifier has got a DC offset problem, I'm pretty sure. Now immediately you can't check it, obviously, because if you connect a DC voltmeter to the output of the amplifier, because the relay hasn't released, you won't see any DC voltage anyway. So you need to take the cover off and actually look downstream of the amplifier's relay and measure the DC voltage at the output of the amplifier. And the easiest point to measure usually is on the emitter followers. You've got some emitter follower resistors, and they're usually sort of very low ohm ceramic resistors, and you measure the center point there relative to the 0 volt connection on the back of the amplifier, or the negative side of the speaker connection, and measure your DC voltage there, because you will see the true output of the amplifier, what it's doing when you're powering it up. But having said that, most amplifiers, the headphone is also wired through the relay protection. So if you've got a headphone plugged in and you switch it on, likewise the headphones won't receive any DC signal if the amplifier is in protection. This amplifier for some reason is different. I don't know why, but I did notice when I plugged in a pair of headphones, after it'd been on for sort of like 15 seconds, I thought, I haven't heard the relay come in, and I was thinking, well, I haven't got any speakers connected, so maybe it has. So I plugged an audio source in and plugged my headphones into the jack with the volume down, and there was this big click, click, click sound, and that's a classic sign there's a strong DC element on the output. So I quickly pulled the headphones out, because likewise that's going to damage the headphone voice coil. So I need to look inside this amplifier. I know these amplifiers suffer from overheating, and you'll see that when I open the top off. Open the top up, and you'll see that sort of everything's a bit discoloured and a bit sort of gone brown where everything's got hot. So let's get the top of this amplifier and see what's going on inside. Okay, this is the amplifier's power amp section, and let me just show you. These are the push-pull drivers that drive the main output transistors. Here are the main output transistors. They're big Sankin things. They're huge, high current capability transistors. This is the emitter follower resistor I was talking about. There's two resistors in a package there, and the center connection. So you've got a resistor from there to there, and there from another side to the center. So that probably goes to the I can't remember. It's the collector and the emitter of one transistor, and they centralize up. And that point there is your left-hand channel, and that point there is your right-hand channel. And that basically, you can see the wires go off, and they go off to the protection relay. The protection relay is just to your right here. This is your protection relay, and the protection relay's DC monitoring circuit is all this part here, and that's looking for any DC offset on the speaker terminals, and won't release the amplifier's relay to connect the speakers up until the DC is gone. You can also see here, and this is notorious problem with these things, is you see the discoloration on the board. Now, that's basically everything's getting too hot. These components are sort of, in my opinion, underrated. They haven't burnt, there's no sign of any burning, so that's good, but the board has clearly got very hot under here. Now, I'm two minds if to change these components or not. Obviously, as I say, the resistors are getting hot, but the components don't look like they're damaged, they don't look like burning. But it's obviously a problem. They're running at their maximum rating. What I would possibly do if I did change these resistors, and at the moment I don't think I will check the resistances to make sure they're in spec. I would fit similar, these are probably quarter-watt resistors, but stand them slightly off the board so they've got airflow underneath them. They're not going to burn the board like that, and the resistor is going to run slightly cooler. And you see how closely bunched they are together. They're obviously sort of like they can't get the heat out. The other problem I found with this amplifier, and I don't want to slack it off too much because it's a good amplifier, I think the cooling is inefficient, or there's not enough of it. Basically, the only vent area in the top of the lid is around this top of this heatsink here, and likewise underneath. So there's no air movement really for the rest of the circuit board. And for the previous time I looked at this, this is a linear regulator for the preamplifier section, or maybe the phone amplifier section, and this thing runs so hot you can't touch it. I mean, that's fairly normal for silicon components. Got no problem with that at all. But that heat's all dissipated into this outside shell here, which then connects to the lid and hopefully is dissipated into into the air by convection. But it does run extremely hot, and this component is really sort of like, I think, probably on its beam end. It could have done with a better system, because it's a linear regulator. It's also affected by if you have the input voltage to it is too high, like you're putting 20 volts in, you want 12-volt regulation. That's dissipating a lot of energy, and I'm not sure. I don't want to get into sort of messing around and things like that. I just want this amplifier to work again. Capacitors in the back here are in the phono stage and preamplifier stage. Now, it's not a problem with the phono amplifier stage, because when I power it up, it's the same in whatever mode I'm in. If I'm in phono amplifier, it still doesn't release the protection, and if I'm in the normal sort of like auxiliary input, it's still the same. It takes the same time for it to release, if it ever does. So the capacitors we really want to look at are the ones in the audio stream, and the first ones I'm going to be looking at is this one here, this one here, this one, and this one. Now these are in the power amplifier stage, and they are most likely going to be the ones that are causing the problem. Particularly these ones here. So you can zoom in a bit without getting out of focus. It's a different camera, by the way. A new Panasonic camera. These capacitors are sitting in a very hot area. You've got the hot driver transistor. You've got the emitter followers that, when the amplifier is working hard, will probably get warm. You've got another power resistor behind here. So these resistors are probably having a fairly hard life temperature-wise. As I say, the heat from the amplifier doesn't dissipate particularly well because there's no ventilation on it. So these are the four capacitors I think I'm going to remove first. I'm going to remove these capacitors. There's another one there actually. You can't see it. It's just there behind that driver. And there's another one there. So those 6 capacitors need to come out. I think we're going to put them on the bridge and see what they measure. Now, I'm not only looking for their ESR. I also want to see if they're leaky, because that's most likely going to be cause the problem. And I'm pretty sure that if I took these two capacitors out of here and powered it up, the amplifier would release its protection circuitry more or less straight away within sort of a couple of seconds. So I'm suspicious of these, mainly these two capacitors here. But and as I say, we'll go through, we'll have a look. Unfortunately, you can't change these with polyesters or anything because they're 47 at 10 volt, and the 47 at 10 volt would be half the size of the amplifier for a polyester. It'd be a huge thing, so they're not going to be able to put anything in there. But we need to put some good quality capacitors in here anyway, if this is the problem. So let's get the back of the amplifier off, or the bottom of the amplifier off, have a look, and get those caps out and put them through the bridge, see what they measure. Right, we're looking at the output of the amplifier now. I'm going to switch the amplifier on, see what DC we get on it. Now this is post the relay protection circuitry, so you'll see that there's probably going to be a high DC offset that's hanging around for quite a long period of time. You'd expect it to turn on, you might see 6 volts, something like that, rapidly diminish away to sort of like 30, 50 millivolts maximum, I should think. Ideally 0. So we'll switch it on, we should see a swing, as I say, the meter going up, then it will come back down, and eventually, once it's got to a level where the amplifier's happy, it will release the protection circuitry. So let's try this and see what this does. It's leveled off, see, and that's dropped back. That's good level there. So that channel suggests that's okay, but it took a long time for it to stabilise. You see it was jumping around all over the place. So that's good. Let's try it on the other side. So I'm going to turn the amplifier off. I'm going to look on the other amplifier, just give it a second to discharge its capacitors. I'm going to do the same thing. I'm going to switch it on now. Same thing, it's all jumping around all over the place, stabilising, stabilising. Once it's down to it, it should release now. There you go, protection circuit's released. So, alright, it's intermittent here. It definitely was worse than this one at home. It wouldn't even release the protection circuitry at all. So let's get these caps out. Let's start on the first couple of caps, which are on the front end of the power amp, and measure those and see what they come out as. Right, let's have a look at the first two capacitors I've taken out, and those two capacitors are in the power amplifier stage, and I want to see if they're leaky really, or if they're if they're okay. So the first two capacitors look C804 and 704, 704, 804, and they're good quality capacitors, and they are, according to this, they say they are, what do they say, 47 microfarad at 16 volts. So let's measure the first one and see what we get. So we're using the DRE, and we're doing this at 1 kilohertz, which is sort of quite a good representation of what the circuit will see on average. And the first one measures 1.4 microfarad with an ESR of 63 ohms. So that's been straight away. Now let's try the next one. That's 1.5 microfarads at 61 ESR. So those two caps are crap. I'm just checking that isn't 4.7 microfarad, but it looks like it's 47. It definitely says 47 microfarad. Okay, so those two caps are going to be replaced, obviously, because those capacitors are basically totally open circuit. They're probably leaky as well. So we'll find a couple of the capacitors. We'll check them on the same bridge, and just to see what the difference is, and then we'll pop them in the circuit. Okay, looks like I found some Panasonic 47 at 50, which is perfect replacement. These should be good quality capacitors. Let's see what these test on the bridge. Hopefully they perform a little bit better than the last ones. That's better. 41 microfarad, 0.7 of an ohm. So yeah, wow, it's night and day, isn't it? Obviously this is a capacitor and the other one wasn't. So let's check the other one just to make sure it's around the same sort of thing, about 41 mic ideally. And get a connection on it. Let's try again. Go. Yeah, it's pretty good. 0.8. So that's the first set of caps to change. So that's the left and right channel of the power amplifier. Let's pop those in. We'll move on to the next capacitors. Okay, got those first two caps changed. The next ones I'm interested in, these 4 capacitors that are 4.7 at 63. You can see that one behind there, just there. There's one here. There's one just where is it? There. Yes, just we line that capacitor there. You can just see it there, and there's another one further up. You might not be able to see it. There it is, there at the top. Those two, there's four. 4.7 at 63. Now, I think I might try, if I can, put a 4.750 polyester in there. That'd be brilliant, because that basically eliminate an electrolytic capacitor that is not necessary. If we can change it with something other than an electrolytic, it's not going to dry up, and maybe we can you know, make this thing a bit more reliable. So let's have a look at what I've got in my stash, and yeah, see what we can put in there. Right, let's check this first capacitor. This capacitor is C713. It's supposed to be 4.7 microfarad at 63 volts. I haven't got any 4.7 at 63 volts. I have got some 3.3 50 volt polyesters that would probably be fine in the circuit, but I don't want to change them unless I really need to. The other option is to obviously go and buy some capacitors. So let me just check the value of this one. And it's reading 3.8 at 0.01 ESR. So this capacitor test is very good, actually. For now, I think what I'll do is I'll leave those capacitors in, and we'll move on and check some of the other capacitors, because I don't want to start buying capacitors I don't really need. Any of these caps are working fine. The Elmer capacitor, as the other one was actually, but it measures perfectly okay. So let's pop this back in the circuit and move on to the sort of next set of capacitors that need to be looked at. Right, let's run through and show you what I've changed. These are the main problems. These series capacitors that couple the power amplifier stage to the preamp, they were basically open circuit. Replaced those with some higher voltage ones, and hopefully gives them a bit more life. Low ESR capacitors. 4 capacitors here, 1, 2, 3 and 4. They're in the power amplifier stage. And these resistors here that are part of the regulator that take the unregulated supply from the transformer and the main smoothing capacitors and drop them down. So these are 4K7 resistors, 3 in parallel, there, and there. I've replaced the resistors simply because I wanted them lifted off the board, because you can see the way the board's gone brown due to the heat that these resistors run at. They're running at sort of 70 degrees C. It's discolouring the board. So I've raised those up. The resistors that actually took out were fine, you know, and they hadn't really discoloured, but the trouble is they're running at sort of probably 70 or 80 degrees, and they're designed to. It's just discoloured the board, and I just think it looks horrible. Yeah, these caps around here that I did replace are tested okay, the ones I took out, but the ones I've replaced it with has got slightly lower ESR. And the reason why I changed them mainly because they're around a very hot area. This amplifier runs incredibly hot for its power rating. It's under heatsink by a mile, in my opinion. It's a very capable amplifier, producing a lot of current into sort of like transient lows and things, and the power supply is very good, but the heat sinking is not adequate for this amplifier, and that's one of the reasons why these things run so bloody hot. And so these caps are, yeah, as I say, they're surrounded by the main output stage, the emitter followers that will get warm if you're driving into heavy load. These driver transistors, which are in AB mode, so they're going to be heavily biased on as well. So basically, I've changed what I think needs to be changed. Gone through some of the other capacitors in the unit, and they all appear to be okay. These sort of rec cabs here will test okay. They've got some stuff at the back there behind that ribbon cable, you can see, and that's all part of the phono stage, and that all appears okay. These electrolytics, they seem alright. They probably could do with replacing. At the moment, I'm not interested. What I have also done is, this is the bias control for the output stage. Now this is a later build of the amplifier, and I can't get a circuit diagram for it. The earlier version has a preset resistor, or what they call the select on test resistor, where you just put like a decade box across the 2 terminals, adjust the bias for the right point, and just solder a resistor in. These have got actually proper adjustments. But what I've done is I've turned this biasing right down, because even with the amplifier in idle and quiescent current with no sound going through it, this heatsink was getting to sort of 40 degrees. And it's just a waste of power. The only effect it will do is probably reduce the crossover distortion slightly. So I think that what we need to do is, because I've turned this bias right down, I just wanted to check the crossover distortion at sort of like 1 watt, make sure it's not unacceptable. Anything below 0.03 5 would probably be fine. I don't know what the spec of this amplifier is. You can usually get a good idea of what the true distortion figure is if you run the amplifier close to its maximum power. So you run it about, this amplifier for example, about 50 watts, and look at the crossover distortion, or look at the distortion on the output. It should be, that will be the lowest point. What tends to happen, you get a sort of like the crossover, the distortion starts very high as you increase the, and as you increase the power it starts to fall, and it plateaus out and then slowly climbs and suddenly rapidly rises and it goes into clipping. So I think this amplifier will be absolutely fine with this bias turned down like this. I'm certainly happy with it running like that. It's not getting so hot. It's not going to life the components so quickly. So all right, let's. I think the next step is get the lid on it, do a distortion check on it, and see how it performs. Okay, let's have a look at the distortion on this. So this is the meter's reading on the right hand side, watts into 8 ohms. So we'll increase that to 1 watt. We'll try it 1 watt first and see what it comes out like. So again, it's close to 1 watt as possible. It's not that critical. We're getting it exactly right, but there we go. Press distortion, 0.01%. Okay, that's pretty good. I suppose we should check the other channels. Let's switch to the. That was the right. Let's have a look at the left channel. Oh, I'll just activate the protection circuitry, and that's probably because there's the audio analyzer's ground. Yeah, so that proves the electronic protection circuitry works. To be a little bit careful doing stuff like this, because if anything's ground, it will you're basically putting a short on the output stage. Luckily we're not driving the amplifier hard, but obviously the protection circuitry works because it's detected a massive spike in current and dropped the output stage out to save the output stage. Okay, and 0.02% there, so that's good. That's fine. What we could do is try it at a lower level. So what I'm going to do is basically go to 19.08 special again. So get our power and reading back. Let's drop it down to 1/4 watt. Okay, so we're trying a 1/4 watt, and then we're going to try distortion again. 0.03%. Just bear with me a minute whilst I get a dragonfly out of the workshop, which is really annoying me. There you go, all part of the service. Okay, so 0.03. Let's switch it to the other channel. I'm just going to disconnect the audio so there's no drive to the amplifier. So it shouldn't activate the protection circuitry or short it out. And 0.03%. Quite happy with that. And what you'll see is, as I said earlier, if I increase the power, you'll see this distortion drop off. Here we go. That's into clipping. It's back again. 0.02, 0.01. There you go. So it's sort of like 0.009. Great, I've got more than one dragonfly in here. Okay, so, not dragonfly, cranefly. Okay, so basically the amplifier is working fine. Distortion is well within spec, so I'm quite happy with that. So the next thing to do is pop the lid on it and have a listen, I suppose. Okay, I'm playing a bit of Billy Joe Spears, Ode to Billy Joe, running at probably about 5% slow, just to avoid copyright. Amplifier sounds nice, everything seems to be working correctly, all the tone controls work correctly, all the switches are quiet, all the contacts at the back seem good. Yeah, it's a nice little amplifier. The things I don't like about it are the inability for it to drive its rated power for more than sort of like 5 minutes before it actually looks like it's overheating. I ran it for 10 minutes at about 15 minutes at 10 watts RMS, and the output heatsink is already at sort of like 55-60 degrees, which is, in my opinion, too hot for an amplifier that's only rated at 60 watts, and when you're only sort of running it at 15% of its maximum power. So I think basically this amplifier is a good amplifier as long as it's got good ventilation and you're not going to abuse it. It has good capabilities of driving sort of complicated lows, i.e. sort of very inductive lows down to 4 ohms. A lot of peak current capability available from the power supply and the massive fat output bipolar transistors it uses. But it can't do that for long. It can't dissipate. It can't get the heat out of the system, basically, which is a shame because it's a very good amplifier. It sounds very nice. It's pretty well made, well laid out, and apart from the caps that have failed and those resistors that burnt the board, this amplifier has been, nothing else wrong with it really, to be honest with you. You can pick these up on eBay for about 150 quid in good working order, for 150 to 200 pounds. It's not an amplifier, as I say, where I recommend you just leave on all day. You turn it off when you've finished with it. You give it ample ventilation. You don't give it to your teenage kids to use it as a disco amplifier, because if someone chucks a magazine on the top of it whilst it's playing at full power, it will just go into thermal runaway and burn out. They're not designed for high powered continuous use, as from what I can see by the design. But yeah, a nice amplifier nonetheless, and highly regarded at Audiolab. And I've enjoyed this amplifier, and it's actually an amplifier I would keep. It's an amplifier that has got a nice sound, got a good reputation. Just a bit of a shortcoming on the sort of like the build quality of the insides, and under heat sunk, to be honest with you. Anyway, I hope this was some interest, and more to come.